Hello and welcome, friends, to Know It All Haven. I'm your host, Thomas, and today we're going to chase one of the most familiar yet mysterious forces in our lives, the wind. Whether it's cooling us on a hot day, carrying the scent of rain, driving mighty sailboats, or spinning the blades of huge turbines, wind shapes our world in more ways than you might realize. But have you ever wondered, how does wind actually form? Let's break it down, starting with the basics. Wind is, in simple terms, the movement of air within Earth's atmosphere. Most of the time, it travels parallel to the surface, and it all starts with differences in atmospheric pressure. Where there is a greater difference in pressure between two places, the wind will blow stronger as it tries to even things out. So, where do these pressure differences come from? The answer lies about 150 million kilometers above us, the sun. Our planet is heated by the sun, but not evenly. The equator gets far more sunlight and warmth than the poles. This uneven heating creates warmer and cooler spots across Earth's surface. Warm air is lighter and rises. Cooler air is denser and sinks downward. Where the air heats up, like over land on a hot summer day, it rises and creates what's called a low-pressure area, or a low. Where air cools and sinks, it produces a high-pressure area, or a high. Air is constantly moving from areas of high to low pressure. This stream of air moving to balance out the pressure? That's wind. But that's just the first layer of the story. There are other factors driving the winds. First, there's the Coriolis Effect, a direct result of Earth spinning on its axis. Because our planet rotates, winds don't flow in a straight line from high to low pressure. Instead, in the northern hemisphere, the wind bends to the right. In the southern hemisphere, it bends to the left. This twist, the so-called Coriolis effect, is why large weather systems, like cyclones, spin in opposite directions depending on which side of the equator they form. Another important factor is the landscape itself. Mountains, valleys, and even lakes or oceans shape how the wind moves. Picture how mountain winds, like the Foehn or Halny, develop when air is pushed over steep peaks, speeding up on the way down. Locally, breezes appear where land and water meet, like the gentle sea breeze we feel at the coast, or the massive seasonal winds known as monsoons in Asia. Wind isn't just a global force, it's local too. Desert storms, gentle lake breezes, or sudden gusts in a mountain pass are all wind acting on a smaller scale, shaped by Earth's features and temperatures. Now, you might be wondering, how do we measure wind? Scientists, meteorologists, have some clever tools. The anemometer measures wind speed, while a weather vane or windsock shows us the direction the wind is coming from. Simple inventions, but oh so important for flying, sailing, and forecasting tomorrow's weather. But why does wind matter beyond making leaves rustle and kites fly? The role of wind in our world is immense. Wind acts as a natural transporter, moving heat and balancing temperatures across the planet, driving weather systems and climate. It helps circulate water vapor, influencing patterns of rainfall and drought. Many plants rely on wind to spread their pollen. No wind, no apples, no pine trees, no grains. And let's not forget, wind powers clean, renewable electricity, turning wind turbines worldwide. Of course, the wind isn't always harmless. When pressure differences grow extreme, winds can reach terrifying speeds. Thunderstorms, hurricanes, and tornadoes are all examples of wind showing its wild side, causing dramatic, sometimes dangerous changes in weather. Still, these are all natural expressions of our atmosphere balancing itself out. So, what have we learned about wind? That gentle summer breeze, or the gust through autumn leaves, is a direct result of the sun's uneven heating of the earth, pressure differences in the air, the spinning of our planet, and the very shape of its surface. Wind isn't just an invisible force. It's a crucial player in Earth's climate, a genetic courier for plants, and a source of energy for our future. Next time you feel the wind on your face, remember, you're experiencing the outcome of vast global processes, moving above and around us, shaping every life on Earth. If you enjoyed this episode, don't forget to subscribe to Know It All Haven on your YouTube. Share the breeze of knowledge. See you next time.